Yeah, hello guys. I hope you all are doing great. And it's been quite a while that we did not connect. So great to be back here. I see a couple of comments. Yes, we did start. If you guys want, I can wait for another couple of minutes for others to join. We have something around 9 to 10 people watching. So, shall we get started? Also, guys, until others join, I'd like to say apologies for the last session, which was postponed, and later it had to be cancelled because we had invited a speaker for you guys who was very well interactive. He got uh, sick all of a sudden and got hospitalized, so we had to cancel that session. But don't you worry, we got you covered. We have rescheduled stuff, and tomorrow on Sunday we are going to cover both the topics which were left in that one session and which is scheduled for tomorrow. So you guys need not worry. So we have something around 8 people watching us. Should I wait for another couple of minutes or should I start? Just let me know in the comments, guys. All right, fine. It's already 6:21, so I think we should not delay this. So let's get started. So, guys, anybody knows what is today's topic? Anybody in the comments, you can let me know what is today's topic. No one. Also, just drop a thumbs up if you can hear me. If the screen and all is clear, just let me know. Okay, so today, guys, we are going to have a quick intro of a very interesting topic that is, um, oops, sorry, I had a network glitch. So, like I was saying, today it's a very interesting topic because today we are going to uh, give a quick introduction to deep learning. So, deep learning itself is a very what do we say vast topic. So today we'll just cover the introduction of it. What is deep learning, why exactly it is needed, etc., etc. So um, today it's going to be introduction to deep learning. So how many of you know what deep learning is? Anyone in the comments, you guys can let me know a one liner about it, or have you ever heard of it, have you ever tried it? Deep learning, and how come it is different from machine learning, what exactly it is. Feel free to drop stuff in the comments. Also, guys, if you cannot hear me, or maybe if you cannot see the screen, you can let me know. You can let me know anytime in the comments. uh, okay. All right, fine. So let me present my screen, and let's get started with the topic. Okay. So yep, today we are going to explore deep learning, which is in week 3, day 1. So, guys, I don't see any comments. Just drop down something, a thumbs up, or maybe a yes, no, if you guys understand what I'm trying to say. Mm, Lucifer says machine learning is where you define features and train the model, whereas deep learning, the model extract features on its own and classifies. Yeah, a very good way of putting that. Yes, that is what it is, but not entirely. Okay, cool. So let's move ahead and first see what did we learn so far in week two. In week two, we had regression, linear regression. Then I think we also covered some topics of logistic regression. Um, then we covered unsupervised, then clustering, and we saw a few examples. So that was week two. And then we had to go for feature engineering, but we couldn't do that. So, feature engineering, let's cover it tomorrow. So, this is what so far we did in week two, and also week two's resources were not shared. So I'll share week two and week three's cumulative resources by tonight or tomorrow night, because tomorrow, of course, it's day two of week three. So um, week two and week three's resources of Kaggle Learn are going to be shared tomorrow, and also I'll share a GitHub repository where you have a short project which you can have a look at. So, yep, that was week two. And things that we missed, like I said, it was feature engineering and resources. So, don't worry, we got you covered. Like I said, we will definitely share all the resources in the groups. If you are not in the group, either in any of our communication channels, please join them. We are already in week three, so it's only 1 week to go. So moving ahead, let's have a look at our agenda. We have come a very long way. Week one, we did introduction to machine learning, and then we saw basics of Python, and then we did some pandas. Then we did a very good example on supervised learning. We did regression, and we built a nice kind of, what do we say, decision tree classifier in week two, day one, and then here we are, August 31, introduction to deep learning. Um, I think it is a very what do we say, vast topic. So I'll try to keep it very concise so that you guys understand it. Also, please don't mind. I'll be switching off my cam. It's consuming a lot of computation space. So I hope you guys are fine with it. If yes, just drop down a thumbs up if you're cool. All right, fine. So, without wasting any time, let's move ahead. So, today we are going to focus on introduction to deep learning and feature engineering, which was pending on week two, day two, will be covered tomorrow. So, again, reiterating this again and again, how to bridge the learning gap. So, just like you're here, you learn from sessions on the weekend, then you have a following week. So, we'll give you Kaggle Learn resources just like we did for week one. Uh, for week two and three, cumulatively, they'll be given tonight or tomorrow night. And then we'll be having AMA and group discussions where you'll be getting a chance to interact with me, with our fellow speakers, and also with each other to clear your doubts. And then we have tasks for you. So basically, you guys were learning in week one and two, so we did not start tasks yet, but now we are going to start it off. So in week three, you will be having two tasks, and which will basically be on Kaggle itself. They won't be anywhere else, and they'll be pretty simple. They won't be any complicated tasks. They'll be basics of what we have covered in the sessions itself. So you need not worry about it, and then yeah, you keep on practicing. So yep, for now let's get started with this. Number one, what is deep learning? Then machine learning versus deep learning. Then let's see a few use cases, and then the very idea behind the usage of deep learning. Then we'll try to write some code to understand that. So if we are cool with it, can we start off? Also, there are a few questions in the chat. I'll try to take them at the last. All the questions I'll try to take at the last, or else. tomorrow night or Friday night, we will be having a AMA session just for you guys, um, which will cover everything in week 2 and 3. So let's keep it a bit longer one, an hour long session, an hour long discussion basically. So where you guys can ask questions and I'll be there to solve them. All right, guys. Also, if I cough in between, please bear with me. I'm a bit under the weather. So yeah, let's get started. So number one, what is deep learning? So basically, guys, um, if you have some really complex data, let's say there is a huge amount of data which is complex and bit hard to understand. So that is where we apply deep learning. So basically, where much more computation is required, um, and much more, what do we say, patterns are to be made out of the given data. So like you learned in supervised, there is one single pattern. So basically there is one dependent and one independent variable, and you just have to sketch out a nice relation out of them and you'll be done. So here it's not like that. It is a bit more complex. It is where real world data, which is like much more complex, comes in. So just like the textbook descriptions, and the graph you see over here, it is a subset of ML. It comes under ML, and all of ML and deep learning, all of that comes under AI. So um, deep learning is not, what do we say, something completely different, but it's like a subset itself of machine learning. And like it's written, it is all about the depth of computation, and depth of basically how deep can I go to find out a pattern out of the given data set. So that is all about deep learning. And moving ahead, firstly, why deep learning? Why exactly do we need that? Why cannot we simply have a linear regression model or maybe a supervised model to um, do all the, what do we say, working? And why cannot we have simple kind of, what do we say, simple stuff, basically simple stuff, just like I said, in supervised models. So let me tell you, first for that we need to have a quick look back at what we learned. First is, if we have a simple data set with nice labels which tell a story. So basically, data set which with, like, what do we say, labels, a label data set, which we see and figure out something. Let's say if I see a plot graph, it is going up, it means okay, something is increasing, an exponential graph. So it clearly tells us a story. When we see it, clearly we can figure out, okay, this is the case. So in this case, what do we use? Supervised, unsupervised, deep learning? What do we use over here? You guys can drop your answers in the comment. If we have a simple data set with nice labels, which tell a story, what do we use? We use supervised learning. And then, if we have a data set without labels, which are a bit tough to figure out. So basically, this data is not telling a story now. It is not making a pattern because it does not have proper labels. So it's unlabeled data. It is like a bit tough to figure out what to do with it. In this case, which kind of machine learning do we use? The answer is pretty obvious. I think you guys can put it in the comments. It is pretty obvious. Okay, I think a lot of people are typing the answer, but unsupervised, yes, you're right. How many of you think unsupervised is the answer? Yes, it is unsupervised. You guys got it right. So this is for, what do we say, the data sets which clearly make some sense. Now, what if the data set is much more complex? For example, image. An image basically can have a lot of parameters, a lot of parameters. So as you can see, we all have faced this. and this meme is very very relatable to a lot of people. So one image can have a lot of elements, a lot of parameters, and what do we say, a lot of things can be deduced out of it. So this is kind of a complex data. So how can what do we say, somebody um, create a story out of it? It can be a lot of things, right? So that is where deep learning comes into the picture. So basically, if I just simply put up a image of a face, or put up a sketch of someone, it it needs a lot of, what do we say, complex computation to figure out what exactly it is, to convert that again into code. So that is where deep learning comes into picture. We cannot do that with regular supervised or unsupervised algorithms, because basically they rule out the use case. So that is where deep learning comes into the picture, because it provides that kind of what do we say, features or algorithms, basically, not features. Very idiotic to say features. Ha. So moving ahead now, the amount of data and performance are interdependent. I hope we've discussed about metrics. If we did not, then let's say that there are three, four different models, be it supervised, be it unsupervised. There are three, four different models. Each model works in its own way and gives a set of predictions. And using some metrics, we can find out how better is a model, how much accurate is a model, how precisely is that very machine learning model giving a prediction. And basically a kind of score, a kind of accuracy score, or a kind of, what do we say, metric to tell that this is how good this thing is performing. So in comparison to machine learning techniques, deep learning algorithms have very high performance. So that is why we use them in what do we say, these kind of situations, because they have a better performance. So um, especially when it comes to, what do we say, a lot of data which is not labeled, not just labeled, it is complex. Got it? So remember why I told complex computations while starting this. So that is how it is, that is why it is. So moving ahead, as you can see, let's say this is a cat. Now we simply have to figure out if this is a cat or not. So firstly, in machine learning, what we have to do, we have to extract the features. Why should we extract the features? Because uh, buddy, what will you feed to the algorithm? Normally you need to feed features and parameters, right? So we need to extract them first. We need to extract that if this has these kind of eyes, if what do we say, it has these kind of ears, if it has these features, then predict, classify, and sorry, then classify and predict that it is a cat or not. So in deep learning, it's not needed. Just like somebody in the comments said earlier, um, the deep learning models, they extract features by its own, because they have that kind of computational power. That is the very reason they are made for. And like the reason why I gave the sketch and face guy example, if I simply put up a face and ask to detect something out of it to a machine learning model, it might not be able to, because it doesn't know what to do with it. It is not made that way. So feature extraction is a very uh, what do we say, plus thing which comes in deep learning. So this is how it goes. um, in machine learning, as you can see the picture, you feed the image of a cat or something, you extract the features first, then train on that features, that this how basically training a kid that this is how a cat looks like. So also, if you guys remember the classic apple example that I always give, um, in almost all of my sessions. If you remember week one, or if some of you are here from ML bootcamp, then you might have a very good idea of the classic apple example. If not, let me repeat. Um, so basically, if we teach a kid that this is how an apple or some fruit looks like, that kid later will be able to figure out, okay, this is apple on itself. And how is that kid able to deduce by itself? Is by the features. Like apple is red in color, apple is basically sweet, it's a fruit, it has that small what do we say, stick on top of it. So that is how that kid is able to figure out the shape of it, the size of it, and the pattern on that, the texture, etc., etc. So all of these are what features. And in machine learning we have to extract them when the data is complex. In deep learning we need not do that, it automatically does by on its own. That is the very reason we call it deep learning. The depth of the model, basically how many layers deep the model is, that better it is. So yeah, this is just a whole gist of deep learning. Moving ahead, so what is a neural network? Okay, before this let me show you a small example. um, Yep. So what number do you guys see here? I need all of you to put in the comments. What number do you guys see? Let's see if your algorithm can predict it or not. Okay, somebody said one. Another person is saying one. Okay, let me put something different. I see two in this. Do you guys see two in this? Okay, still you guys are sticking to one. So now let me tell you how it works. Just a minute. Let me. Yep. I hope you guys can see the screen. Yeah, let's see an example. Yep. So basically, what happens is this is one. I'll scribble over here itself. Just drop me a thumbs up if you can see the screen. And if I need to zoom or zoom out or zoom in, just let me know. Okay, so basically, you guys are saying that this is one, and yeah, I agree that this is one, but machine learning might not agree to it immediately. Sorry, whatever algorithm, not just machine learning, any deep learning or any algorithm might not agree that it is one immediately. So what I'll do is I'll segment this image first. I'll make some slices out of it, and I'll see how exactly it is made one. So basically, it can also be two, because as you can see here, there is this curve, and this is how two is also written, right? So two is also written this way. People write two like this. So it can be two as well. So there is a chance that our algorithm can also predict that this is two, because see, almost it is the same. And also there is also a chance that it can predict it is one, because it is looking like this. So what happens is I'll show you. um Let me get rid of this first. Yep. So as you can see here, the image basically gets segmented, got it, into very small segments. Okay, let me just go back and check if you guys can see the screen or not. Yeah. Okay, also guys, you can drop down in the comments if you have any problem, if you want to zoom in, or if I'm not clear enough, or if the screen is blurred, just let me know. Okay. So yeah, so like as you can see, here basically we are not extracting features, just like we discussed earlier. Here we are, what do we say, just a minute, hold on, let me go back to the presentation. Where is it? Yeah. Okay, here, like I said, it can also be two, it can also be one, but here we are not extracting the features, that is not in our hand. So basically what happens is, based on the use case, here I'm taking the example of detecting a digit. So here basically the model runs a lot of iterations, not one, not two, many iterations, that too a lot of times, not just once, not just twice, a lot of time it runs many iterations. And as you can see over here, it forms like a chain. Got it. So I'm telling in very layman, very, what do we say, crude terms, so that you guys understand. Uh, there are a lot of beginners who don't understand, so I'm keeping it very, very, what do we say, layman. So it runs a lot of iterations on itself multiple times, not once, not twice, multiple times. So once it is done, it figures out, it basically feels like, okay, this is how one looks like. So now what it does is, it kind of creates a matrix where, as you can see, this is, let's say, this is the matrix that I created for myself. Matrix is in the sense like, basically a box or a field kind of thing of some size. In that, at all of this portion, well, I don't have a paint kind of paintbrush over here, but I'll just try to explain you guys. In the white kind of portion, there is nothing written. So basically what our neural network does is, what our base the deep learning algorithm, let's not call neural network right now. So basically what our deep learning algorithm does is, it says here nothing is written, so I'll just simply mark it as 0, and wherever the stuff is written, I'll just mark it as 1. So if I do this, it'll be like 0 0 0 0 0 0. All of this will be 0 till here, and here it'll be 1. Okay, you guys cannot see this one. So it'll be 0. Here it'll be again 1 1 again. Here this whole thing will be 0. Got it. Okay, let me bold. I'll change the color if possible. Yeah, cool. So yeah, as you can see, um what basically it does is, it creates a matrix. So it does not just create a matrix, it segments the image. So just like that, it uh, kind of outlines the image, outlines the data, whatever is present in the image, not only of this number one digit, but of any other image. If we put, firstly it segments it and understands, okay, this is how the number one image looks like. So just like I gave the apple example, it understands, okay, this is how an apple, or this is how a cat, or this is how a number one looks like. And then later it figures out, okay, if this is the case, then I have to what do we say, give the output of 1. Got it. So now here, um after what do we say, it segments the image, everything, it can also predict that it is 2, but not right away. It can tell that it is like 90% this is 1. There is a chance that there is 10% this is 2, because it looks like that simply. Now it makes sense, right? I hope you guys are understanding. I hope you guys are like at least trying to what do we say, process what I'm trying to say. If yes, just drop down a thumbs up in the in the chat, or else I'll try to slow down a bit, or maybe I'll try to explain it in another way. Okay, so just like this, as you can see over here, just like I said, it segments itself. Now here, all the black part is taken into zeros, and the white part is taken into 1. Got it. So this is how it works. So similarly, like this, we can do a coded example with MNIST dataset and see how this works live in action. We'll do that, but before that, let's brush up some basics. So I told a neural network, right? So what basically is a neural network? So if you guys have paid attention to the last week's topic, basically taking logistic regression and repeating it two times is a neural network, a single neural network, what I call as a very small, a very what do we say, basic neural network. And if you guys don't know what logistic regression is, if you have missed last week's session, please go have a watch, or we will definitely give you the resources for Kaggle Learn. You guys can watch that also. So a quick recap: this is what logistic regression is, where either a yes or a no is predicted, either a zero or a one. Now I hope you guys are understanding why am I taking zeros and ones. So either a yes or a no is predicted. So let's say that how many of you have registered but are not attending? So um, it is either a yes or a no, so there's no in between. So basically logistic regression is, what do we say, a classification kind of task where the probability of an instance is predicted. And once a kind of, what do we say, um, a mathematical expression is driven out of it, you get something called as a sigmoid curve. I'm putting it down in the chat. Excuse me. Yeah. So what you see here on the screen is a sigmoid curve. That sigmoid curve comes from all the way below the graph, that is from 0 to 1. And just a minute, let me show you another graph as well, or else it might be a bit more mathematical for you, or else let me keep it very straight. So the dependent variable here is y, and the independent features be x. So here now y is basically either 0 or 1, the dependent variable. It is either yes it is done, or no it is not done. So not just that, as you can see, there can be also near it or not near it. So as you can see here, somewhere y is 0. 0.3 and there it is 0. 0.8. So that is what logistic regression is. So now, when you apply logistic regression on multiple iterations, you form a neural network. As you can see over here, as you can see, px1, px2, px3, multiple times. These are on what do we say, x, that are features. And guys, if you are finding a bit of problem understanding the mathematical terms, if the math is not mathing, then I request you guys to please brush up a few basics. This is very like elementary, you guys need not worry about it. Just brushing up a few basics will do. So like basic statistics, matrices, and especially functions, um, and what do we say, basic mathematics will help you understand what exactly is going on. So that is one thing. And yeah, as you can see in this graph, let me show you a much better full version of this graph. I had it somewhere. Hmm, yeah, here it is. Let me present my screen. Yep. Hold just a minute. Yeah, this is the image I was talking about. So as you can see, just the extended version of that one. Let me present this completely. Yeah. So as you can see here, um, like I told, on the input layer, not on the input features. On the input layer, we are taking what do we say, px1, px2, px3, and they are what do we say, iterated multiple times, so that once what do we say, a sigmoid curve comes up, a sigmoid function comes up, then it comes up another time. So as you can see over here below, it is um, clearly mentioned that where the part 1 of the logistic regression is happening and where the part 2 is happening, and also cumulatively you're getting two sigmoid graphs, and which is pointing to one output layer. Got it? So basically it's like um, taking multiple inputs, figuring out something out of it, and then slowly moving towards one output. Got it? If not, if you guys have any questions, if you guys have any um, problem understanding, just let me know. I'm trying to keep it as layman as possible so that you guys understand. um, Let me give a better explanation. So basically, let's say that there is one input layer, and then there are multiple hidden layers after that. So input layer is where the object's information, like all the features, x, just like I told, x are features, right? So which is present, like all the features go in, the maybe the shape, color, texture, etc., etc., all the features. So you guys might be curious, like how does a deep learning algorithm or a neural network automatically um, detects all these features, where in machine learning we have to what do we say, do feature extraction, and do all the feature stuff. How does it do? This is how it does. On the x layer, as you can see, px1 can be taken as feature 1, can be taken as feature 1. I'm not saying it should be. So basically the first layer is where all the features go in, the shape, color, etc., etc. Then the hidden layers in between, they analyze all of these things, right? So these things, what do we say, they kind of cook up something, analyze and understand, okay, if these features are there, it is what do we say, pointing us towards this. Okay. So now if I say, in these features, if it finds what do we say, red in color, sweet in taste, etc., etc., the shape is like this, it has a stick on top, then slowly it will realize towards, yes, it's an apple. And then at the last what do we say, I don't want to say node, the last layer. The last layer would be the output layer. It will clearly say that it is an apple or not, it is a cat or not. That's it. Very simple. So it's like, what do we say? Think of playing a game where you are asked a lot of questions, where you narrow down the possibility and figure out the right answer. So that is how it is. So it is basically narrowing down all the possibility by multiple analysis, doing multiple layers of analysis. That is how a neural network works. Is it fine, or should I give a much better or a much easier example? um, in much easier example, I can say that layer 1 sees the picture, and layer 2 thinks about all the hidden layers. They analyze all of these. They analyze all the, what do we say, um, all the elements of the picture, and the output layer, the last layer, decides, like, okay, this is this, and this is how it is supposed to be. So that is also how, what do we say, I don't want to say that is how logistic regression works. It is like, what do we say, one way of looking at it. So let's do one thing, let's dive into the code. You guys might not understand, so let's see an example. I'll try to present Kaggle for you guys. I have a small example to show. Let me put it up. Also, if you guys want to uh, code along with me, feel free to do it. I'll give you the Kaggle notebooks link. If you really want to code along with me, you can um, put it in the comments. I'd love to give you the notebook link so that you guys can code along with me. Okay, guys, can you drop down thumbs up in the chat if you can see Kaggle? If you cannot see Kaggle, then just let me know. Okay, yeah. I hope you guys can see the Kaggle window, because I really don't think you guys can see. Just put it down in the comments if you guys can see the Kaggle window code, basically, not the presentation. If not, also please put it in the chat. Okay, yeah, I think I'm presenting the wrong tab. Just a minute. Also, guys, yeah, this is the, what do we say, Kaggle Learn activity that you have to do. I'll share the resource of this one, and also for feature engineering and the things which we left in week two, tonight or tomorrow night. So before that, let me check, where did I put this? Day two, day four. Nope. or else let me create a new one for you guys. I had the demo somewhere, I cannot find it, sorry. Let me quickly create a new demo. I'll just call it ML Study Jam Deep Learning. Alright, cool. So, firstly, guys, what I'll do is I'll get rid of all of those things first. Yeah. So, now what to be done is firstly, let's understand what we are trying to do. What we'll try to do is predict what do we say, digit, a handwritten digit. So I'll just put it in the comment, predict the hand drawn, or there's a hand drawn digit. So what we will do use is we'll use the MNIST database. So MNIST means modified National Institute of Standards and Technology database. So it is a large database of, what do we say, handwritten digits. So we'll use that one. Okay. Yeah, we'll use the MNIST database. So let me show you how it looks like. So just a minute. I think I cannot paste pictures in Kaggle. I'm not sure. Let me check. Yeah, I think I cannot paste it. I'll try to do it in Markdown. Yep, think so. Yeah, this is how MNIST database looks like. It has a lot of hand drawn kind of digits, hand drawn digits, and hand drawn numbers. So we use this, uh, train it over a neural network, use a deep learning algorithm, and try to predict something out of it. So yeah, let's go ahead. Let's not waste time. So for this, firstly, I need to import the MNIST database. So what I'll do is simply add an input from here, and I'll search for MNIST. Nope, not this one. There's CapsuleNet. There is MNIST in Kannada as well. I was not aware of that. So there are a lot of datasets. Let me use a better one which has much detailed data. Hmm. Or else let me use TensorFlow for importing the dataset itself. I think in TensorFlow in Keras itself there is MNIST dataset. So what I'll do is I'll simply copy paste all the import statements over here. So I'm importing TensorFlow. Um, you guys, of course, you know what TensorFlow is, so I need not explain again about it. So from here, something called as Keras datasets, we are importing MNIST. So from here, we are, whoops, something wrong. Okay, this became Markdown now. My bad. Okay, from here we are importing the dataset, and we are importing something called as sequential. So I'll tell you what sequential is once we go further. Okay, so let me try to first print something from the dataset just to make sure I have properly imported it. Mm, it works, I think so. Okay, Yep. So I've did a very simple thing. I have used something called as basically I've used load data function, and I have loaded my data set. And let's see. Okay, so yeah, as you can see, all of this is an array. And guys, can you tell me why this is what do we say, in zeros? Here you can see a lot of zeros, there will be also ones, I think. So why is it like this? Why is our data set like this? Or else let's do dataset dot head. I think I won't be able to do that. Yeah, so I think I need a pandas data to convert it to a pandas data frame. So simply if I load this, it is all zeros. There will be also ones in between that. Can somebody put down in the comments why it is like this? Because we discussed something really interesting today, and I also showed you some of my art skills, which were not at all good. So, can some of you tell why are we seeing a lot of a lot of zeros uh, in a very well what do we call, well, very well articulated, not articulated, very well arranged form? Why do we see a lot of zeros over here? Why MNIST dataset has these many zeros? Anyone? You need not worry about wrong or right answers. If you remember that, I told something about zeros and ones regarding a hand drawn digit. I also showed you a small example. Lucifer says zeros probably represent the white pixels uh, in the image, or the pixels have nothing. Exactly. And one would represent the pixel where the hand drawn digit is there. Exactly. So basically, that is why we see a lot of zeros over here. And in between, somewhere, yeah, there might be one as well. Of course, there will be. So now we have nicely loaded our data. What to do with it? We'll train test split. So that is a very generic thing to do. So what I'll do is, I'll simply take some part of it for training and some part of it for testing. So firstly, let's train our model. What I'll do is I'll take X train and Y train, and then I'll take X test and Y test. Test. Okay, so I have taken just a minute. Yep. So this is a kind of, what do we say, simple way to split your model into train and test. You can do it this way as well, and simply instead of re-rendering it multiple times, I'll directly throw down MNIST dot load data into the split itself. I'll simply remove this line of code. It will save me something. So it'll save me a line of code, of course. So I'll directly load the data into training and testing itself. uh, is it done already? Let me have print completed. Yeah, completed. So this is done. Also guys, here, if you don't know, like we discussed in week one, it was very back, I think day one, it was on day one. Code executes line by line, so until this line is not executed, this won't reach. So that is why I have a print statement over here. It not only here, almost everywhere, every single where, irrespective of framework or language, it does the same. So now what we did is simply splitted it into train and test. So now what I'll do is, I have something already written. I'll simply copy paste it and I'll explain you the lines of code. So now here I'm reshaping the data, and both the X train data and X text test data, and I'm reshaping it over some kind of value. Anybody knows why am I doing this? I hope most of you don't, but does this make sense? What does it exactly mean? Okay, so let me tell you what all of this means. Firstly, here when we reshape the data, it, what do we say, reshapes it into a two-dimensional array. So as we can see here, I think I did not print that somewhere. I removed that code. Let me print that again. I'll just simply print xtrain. Okay, as you can see, there is a multi-dimensional array. There's like a list of a list of a list, and in even in that there are what do we say, a lot of stuff. So basically what this piece of code does is, um, it reshapes the data into a two-dimensional array, so that it becomes very easy to train our model, and easily our model can analyze it. Number one. So either into a two-dimensional array for uh, or we can also do it into a single dimensional array, but I think it won't be required now. So now the training data set, as you can see, it is changed into a two-dimensional array with something around 60,000 samples for training. What will happen is, it will use, because we mentioned 60,000, it uses 60,000 samples for training, and in test it uses 10,000 samples for testing. Got it? So X train takes something over 60,000, and uh, X train takes over 60,000 to train, and X test takes something around 10,000 to test. So if I'm not clear, just let me know in the comments. I'd love to retell anything uh, another time. So moving ahead, now what is float 32? So guys, some of you might know what it is. For the people who don't know what float 32 is, um, basically it's a kind of what do we say, type. If you guys don't know, float 32 is a kind of computer format, not our general format like what do we say, a string or something, etc., etc. So float 32 is something that occupies 32 bits in a computer memory basically. So we are simply converting into float 32 type. Got it? So we are reshaping the data and converting it into float 32 type. All of that for easy computation and easy analysis. So we are simply making it simpler. That's it. And now, why did I divide it with 255? Simply, I'm taking 255 pixels. So you remember that segmentation part where I took the container and I told that let's assume that it's a matrix and we segment the data. I simply divided in 255 pixels. In that 255 pixels, wherever there is 0, it is a white space. Wherever there is 1, there is a what do we say, drawn space. Got it? So, chalo, this is all about this piece of code. Now, what about this one? What is keras.utils.to categorical, etc., etc.? What is this? Let me tell you in a very easy way. This is called as one hot encoding. Yeah, one hot encoding. So basically now we have image data. We need to convert it into code, right? So what this does is two categorical. Let me hover on this. It will show some data. It is not showing. It should basically. Okay, fine. So basically, what does this do is basically it does one hot encoding. Why do we do this? So as you can see, that image data needs to what do we say needs to be fed to the machine, and that machine needs to understand what do we say that data. So we basically one hot encode it into that language which the machine understands. Got it? So machine understands code. So basically what we are doing, making the image data into something like binary zeros and ones. So that is what is called as one hot encoding. Not only converting it into binary, anything. Let's say we have uh, 10 samples of data. All of the 10 are unique. We can number them: sample 1, sample 2, sample 3, etc. So this kind of numbering system the computer can understand. Okay, if it is 1, then return this kind of. So that is why we are one hot encoding it. This whole process is called as one hot encoding. So we are using this tf.keras.utils dot two categorical to implement one hot encoding and arrays sorry um, what do we say some kind of uh, what do we say random data can be converted into what do we say computer understandable array like class value which consists of zeros and ones. So this is just for the computer to understand, just for our machine to understand that this particular image looks like this in terms of what do we say zeros and ones. We do this. Okay, so this is done. Now our model will definitely understand that number one would look like this. What to do now? So what we'll do is we'll use something called as sequential. Uh, do you guys remember where did we talk about sequential in import statements? Right, I told you that I'll tell about it later. So what does this sequential do? So basically, the sequential does nothing. It puts all the layers of our neural network in a very nice sequence. So what are we doing is we are using something called as ReLU and softmax. I'll tell you what are these once we what do we say predict some value. So we are using the sequential model. We are calling our model sequential, not calling our model sequential. Basically we are using the sequential model. So what is the dense what is this value and what is this value, what is this function and what is this function, I'll let you know. So basically for now consider this as our deep learning model which allows us to predict the digit using all of the stuff which we did here. So moving ahead, mm, what I'll do is before directly fitting just like we did earlier we fit the model, right? Instead of directly fitting, I'll compile it. I'll use a optimizer called as Adam basically is a model optimizer. Acha, okay, I did not run this one. Firstly I'll run this, then I'll run this. Yeah, so now it's completed. So and here I'm also checking the loss of it. So I'll use accuracy metrics and I'll use categorical cross entropy to monitor the loss as well, because whenever you train a model there can be some loss. So that loss should not be more. If that loss is more, then your model is not training properly, it won't give you accurate results. So that is where we kind of what do you say monitor all the stuff. That is done. Now it's time to fit our model. We have compiled it, we have like called the model, we have compiled it, did etc etc. Now let's directly do model dot fit like we did earlier. And now guys, I want uh, some of you to tell on what things we will be fitting the model. We will be fitting it on X and Y, right? So we'll be fitting it on X train and Y train. And here, let me introduce you to the concept of epochs. I think earlier we did not speak about epochs. So now I will tell about it. So this is basically how we do model fit. We do features across labels and we fit it. But here, let me also specify that I'm going to do it over 5 epochs, and each size I mean what do we say, each time we'll take the size of 128. Got it? So something wrong. Okay, let me see what's wrong. Okay, before that, let me tell you what oops, just a minute. Let me tell you what an epoch is. Let's say you start training a model. Model training starts, and then model training ends. You trained a model. Basically, this whole was the process of training a model. Now there's one epoch. Got it? So basically, 5 epochs means training the model 5 times, multiple times, again and again. It's like a reiteration. Got it? So here I had some problem. Invalid input shape. So I already shaped the data. Some problem is there. Okay, let me remove the batch size and let's try. Okay, error again on the first epoch itself. So, I think I did not run this one. Run this, run this, and run this. Now this. Okay, another error. So, uh, let me try to fix this error first. So, also, I hope you guys understood what epochs mean. So, number of epochs can be increased. It can be 10, it can be 5, it can be less, depending on what use case it serves. So let me do one thing first. Let me try to fix this error. Sequential.call. Okay, shape is this. uh, it is expecting 28 by 28, but the shape is wrong. I think I need to change the shape. Hmm. 32 by 784. Let's change it over here directly, which I don't suggest you guys to do, but just for the sake of this demo, I'm doing it. 784. I think I should not be doing this. Okay. Nope. Uh-huh. Interesting. So I'll simply reshape the tensor again. Here, let's keep one. I'll run this again. This should work. Did not work. Okay. Hmm. All right, fine. Let me figure out how this works. Hang on tight. Yep, I know it's been more than an hour, but yeah, just hang on tight. Let me figure it out. Okay, I think I need to do this for Y as well. Now we have a new error. Yep, progress. Hmm. Okay, guys, you guys have been waiting for a very long time, so let me not waste your time. So, yeah, let me quickly fix this. And I'll do it only over X train features. Let's see if this works. Huh. Interesting. Nope. Yeah, so somewhere near shaping our data, there was a huge mistake. So, not huge, it's a blunder actually. So, let me check what can I do with this. Yeah. Okay, guys. Looks like the demo is not in my favor today. Throwing a lot of errors. So yeah, I don't want to waste your time um, fixing the code. So yeah. Um, Let me just reiterate what we were going to do. Just like, okay, this is the very reason I showed you this very image. Um, we took a 28 by uh, just a minute. Yeah, we took the input shape as 28 by 28, and all of these empty values stood as 0, and these stood as 1. So the input layer, I hope you understand now why we took 784. So on that on that note, this makes a lot of iterations by itself, forms a kind of network. That is the very reason it is called as neural network. And why it is called as neural, from where did that word come, is because also our brain works similarly. So that is how this was deduced. So yeah, if we really have to predict this one, um, it would be something like this. So not only for this, for NLP, for a lot of things, we use deep learning, and we will see all of those examples tomorrow, because today's session was only for the introduction. I hope you guys understood a lot, and we had a very bad time struggling to make the demo works, which did not happen. So yeah, let me come up with a pre-written code tomorrow, which would definitely work. So I have a small announcement to make over here. Week three's AMA will be scheduled on Friday night, that is on 6th of September at 8 p.m. At 6th of September on Friday night at 8, or sometimes at 8:30 or so. There might be a 10-20 minute difference while we start. It'll be a Google Meet. You need not worry. You can speak to me and get your doubts cleared. So yeah, it'll be scheduled on Friday night. If any of you want an AMA before this, just let me know in the comments. I know there are a very few people watching. Just let me know if you guys want it before. Also, you can let me know in the group. There is a general discussion channel, there is a doubts and questions channel. You can let me know there as well. We will definitely try to make a better timing, or make a much more feasible schedule for you guys. So yeah, that is it. And that is it about deep learning today. So thank you so much, guys. Hope you had a very insightful, very resourceful session today. Thanks for bearing with me when the demo did not work. Yeah, it is what it is. So that's it for today, guys. Thank you so much. And the resources will be shared in the WhatsApp group tonight or tomorrow night, which will cover the leftover topics for week two and the topics of week three. So make sure you guys complete the sessions on Kaggle Learn. The Also, there are a very nice kind of assessments that you can give on Kaggle Learn. Once you complete it, you will automatically get a certificate which is shareable. And don't forget to brag about it on LinkedIn once you complete Kaggle Learn activities. So that's it, guys. Thanks for bearing with me. Let's meet tomorrow at the same time. Tomorrow we have another very interesting topic, that is computer vision. So just like we did for MNIST datasets today, let's tomorrow discuss for how stuff works when there is image data, and especially when that is vision based data. So a really exciting topic. I hope you guys are as excited as I am. So let's meet tomorrow. That's it for today. If you have any questions, feel free to put them in the group. You will be answered definitely. So thank you so much. Have a good night.